Hello class, this is our lecture in our module 2, the mixture of ideal gases or the Dalton's Law of partial pressures. Now, before you arrive at this Dalton's Law of partial pressure, sa may last module nyo, na-discuss sa inyo yung about the characteristics of gases. And by the way, this PowerPoint is made by Sir Paul Jan G. Eugenio, my colleagues in the Department of Chemistry. Okay? Okay, balik tayo. Okay, sa may ko ninyo, saan inyong last module, you talk about the pressure, volume, temperature relationship of gases. It also known as the Boyle's law, the Charles law, and Gay-Lussac's law. That's the PBT relationship. Now let's impose in the PBT or the combined gas law, the Avogadro's law, and the gas rate constant. Ayan. So, diba you have a PBT relationship. Ayan. Dito. Now, let's impose dito yung Avogadro's law and the rate of the gas constant rate. We will give a rise of the famous equation of ideal gas, also known as the PV-nRT. And you're all familiar to it kasi nga, na-discuss ito sa inyong general chemistry. Now, in this PV-nRT, guys, ito yung gagamitin nating equation sa ating Dalton's Law after we impose that equation here. And mag-jump tayo sa may slide number 34. Okay, wait lang. I'm having some technical problems. Okay. So, ayan. Dito tayo. So, sa may Dalton's Law, ang in-state dito is that the total pressure exerted by a mixture is additive. Pero hindi siya ibig sabihin na siya ay extensive property. Pressure is an intensive property because it does not depend on the number of particles. So, ayan. So, it's a P total. Additive yung pressure natin in a reaction mixture. Kung ano yung pressure na ine-exert ng water and hydrogen molecule, yun yung total na ine-exert ng pressure nila. So, it is an additive. Let's suppose at this mixture here, ayan. Suppose, ayan, sa ating mixture na ito, here, di ba? P total is the pressure of all is the sum of the total pressure present in a gases. So dito sa ating kuha natin, here, dito, lang guys. Ayan, kung mapapansin ninyo, so ano ang total pressure na ine-exert ng reaction mixture na ito for the decomposition of sulfuric acid? Diba sa Dalton's law of partial pressure, we have P total is equals to PA, PB plus PC or whatever gases na present. Ayan. So dito, ang magiging P total natin or pressure total for this is the pressure exerted by the water vapor and the hydrogen gas. And take note, guys, that the liquid is not contributing to the pressure of gases because it is fluid, although it is fluid, but it's not contributing to the pressure of the gas. Ayan. So, ang pa natin, P total in this reaction mixture, again, is the pressure exerted by the water and the hydrogen gas by the decomposition of sulfuric acid with the same catalyst. Ngayon, ang concept na ina-apply natin dito is, dito na natin i-impose yung ating gas law. So magkakaroon tayo ng series of derivations here. So I hope you can keep up with me. And ayan, so I will permit you to take screenshot naman kasi this is for purpose of public viewing. Post naman sa YouTube. Ayan. So let's see here. So let's derive the equations here. Ayan. Wala pa rin. Let's derive the equations for this one. Now, balik tayo sa ating kwan. Let's impose the Dalton's law. Ayan. Let's impose the Dalton's law to the ideal gas equation. So how do we do that? Okay, first and foremost, diba, we have the Dalton's law. Suppose that we have three gases. We have gas A, gas B, and gas C. So the P total expression for this will be the pressure of A plus the pressure of B plus the pressure of C. Now dito sa ating natin, we will impose the ideal gas law. Let's assume that all the gases are exhibiting an ideal behavior. Now, di ba, once we derive this ideal gas law, we will have an expression of, ibababa mo lang yung V, we will have nRT over B. Yan. So, ang mangyayari ngayon dito will be the P total expression here, the P total expression will be, ayan, so the PA, i-impose natin to for the mole A NART over V, and the volume is the same kasi nasa isang container din lang naman sila. The V and T has the same value for each gases. Kasi nasa isang container naman sila. So, ayun, inulit ko lang din. So, ayan. For gas B, ayan. So, NB over RT over V. And then, plus the PC. Ayan. So, NCRT over V. So, ganyan yung expression niya. Diba? Kasi, since the expression of the pressure is nRT for the moles of gas A, gas B, and gas C. Pero dito kasi N1. So, masusundan nyo naman yan na ganyan. So, same lang din. Nag-iba lang ng subscript doon sa ating ko natin. Ayan. So, ano bang significance dito, sir? Bakit natin dinerive ito? Kasi nga, as you can see here, we have a common factor. Sir, what is the common factor? Ito, the RT over V. So, for that, we can isolate it as, ayan ikuan ko muna, i-derive ko muna sa may expression na maintindihan ninyo before we rearrange this into here, di ba? So, the common factor sa may math ninyo is RT over V here times the gases, di ba? Na plus NB plus NC, which is N, di ba? The moles of gas A, the moles of gas B, and the moles of gas C, and so on and so forth. So, ayan yung common factor niya, di ba? Ayan. So, rearrange the equation. Let's just rearrange the equation. Ayan. So, we have the mole of gas A plus the mole of gas B plus the mole of gas C. And by the way, letter N po yan. Okay. Ayan. So, that's a RT over. And then, let's impose dito. So, we have this expression as our equation 1. And then, punta tayo sa may ating mole fraction concept. Saan yung mole fraction concept? Napag-aralan nyo yan noong kay General Chemistry. It's the part of the solution. Kasama yan ng molarity, normality, molality. Ayan. So, the mole fraction and normality. Ayan. So, mole fraction, impose natin. Let's suppose that the mole fraction A, ayan. So, hindi tayo mag-express dito as 1. So, I'm using letters. Okay? I'm using letters. So, para hindi kayo malito. So, let's have this N1. This one is N2. This one is N3. This one. Ayan. So, letters na lang para 1. So, sorry for that na lang. So, this one here is the mole fraction of 1. Okay? So, the mole fraction of 1 in this equation, di ba? We have a... Teka. Magkaagulos. Let's suppose that the NA is equals to N1, NB is equals to N2, and then yung NC natin is equals to N3. Ayan, pare-parehas. Okay? Ibahin lang natin expression. I-conform lang natin siya dito sa may PowerPoint na ito. Okay? So, yan. So, the X1, di ba? In this equation, we have the moles, di ba? It is the mole fraction common is the mole fraction, moles of 1 all over the total moles. So what is the total moles? In expression, the total moles is also known as the NT, which is the sum all of this, di ba? So the N total, ayan, if we express this to another equation, we have NT or the N total all over RT over B. Ayan, so where NT is the moles of the N1 plus N2 plus N3. Huwag kayo malilito hindi because the NA is equals to N1. We are going, nag-confirm lang tayo sa may PowerPoint ito. Okay? Ayan. So, that's the NT. So, therefore, it is ang expression ng ating mole fraction. Balik tayo dito. N1 all over NT. Ayan, di ba? And then, we have here, ang mangyari dito is the N1 is equals to N1 plus N2 plus N3. Sinubstitute lang natin, expand lang natin equation kasi nga NT is equals to N1 plus N2 plus N3. So, ganyan yung mangyayari dyan. And then, after that, babalik tayo sa ating ideal gas equation. Di ba? Okay, balik ulit tayo sa may PB is equals to nRT. Okay? Na kung saan, let's isolate the N by which yung N natin nasa an expression of ibababa mo lang RT. So, N is equals to PB all over RT. So since nasa isang container lang naman sila, di ba? Ang gagawin mo dito, this one is the N1 and P1. Kasi nga, same volume, same temperature, kasi nasa isang container sila. So let's expand the equation further here. Ayan, as the X1. Ayan. So the N1, the moles 1, ayan. Expand na natin the equation. The N1 as an expression of P1 times V all over RT. Okay, nagtitipid lang ako ng space, guys, ha. Pwede rin siyang ganito, oh. Ayan, oh. So, P1, ayan, P1 or P1 all over V over RT. Nagtitipid lang ako ng space, ha. Kasi pag pinag-times mo naman yan, ganun din naman. Tama? Okay. So, here, babalik na tayo dito. So, P1 all over V RT plus P2 all over V all over RT plus P3 all over V over RT. Ayan. So as you can see here, we have a common factor P all over RT. Ayan. So ang mangyayari dito is P1 all over P1 plus P2 plus P3 times the V all over RT. Tama? Ay, gumawa na ng mouse. Asan yung mouse? Ayan. So, from this equation, ang mangyayari dito, ayan dito, di ba? So, common factor, sorry guys. Ayan, the common factor here, nagkamali ako. So, common factor, ayan, pala, sorry. So, V over RT, disregard this, ayan, V over RT, here, times V all over RT. Na kung saan pwede na silang mag-cancel to get the expression of P1 all over P1 plus P2 plus P3. So, pinaita ko lang yung relationship nila. Ayan. So, kung i-relate mo siya dito, ayan, let's say that the P1 is the P total. Ayan. So, P1 is equals to P1 plus P2 plus P3. So, let's compress that equation. So, we have P1 all over PT is equals to X1. So, kung ang given ay mole fraction, ito ang expression na gagamitin nyo for the Daltons Law. And so, that will be our expression. And so, ano ulit yung mga formulang na-generate natin, guys? We have the partial pressure P total. Ayan. So, we have P1 plus P2 and P3 for the Daltons Law. And then, in relation to that, kung makikita nyo dito, ayan, sa ating pinaggagawang, ayan, oh, anik-anik dito, here, it's just to show some sort of derivations para lang mag-arrive tayo sa may expression na ito. And as you can see here, yan po yung mga pinaghugutan ng mga equations na yan. Pinaita ko lang na hindi basta-basta na formula lang yan, ganito, ganyan. So, ganito gamit yan. Hindi. May mga pinanghugutan yung mga yan. Kaya ako nag-derive. So, for that, these are the equations na generate natin. Ito. Ayan, this is just to show. Ito, pinakita ko lang dito yung summary. So, ang equation lang na gagamitin natin is the P total and then the some sort of derivations to arrive here. Ayan, no. So, in summary, the mole fraction is equals to B fraction is equals to 3 fraction. Ayan. So, if you want to take screenshot for the derivations, kindly take it na lang. Ayan. So, these are the derivations. RT over V, the P total. Ayan. Yan. So, these are the equations. Napunta na tayo sa ating sample problems where we are going to apply all of the equations na pinagsasabi natin kanina. Okay. For exercise number 1. Ayan. Hydrogen gas is collected at 22.5 degrees Celsius. Find the pressure of the dry gas if the atmospheric pressure is 94.4 kilopascal. The vapor pressure of water at 22.5 degrees Celsius is 2.72 kilopascal. So, ang gagamitin na expression natin ito is yung ating equation 1. So, P total is equals to the pH2 plus the pressure of water. The pressure of water measured at 22.5 degrees Celsius. So, nagmamatter temperature dyan, guys. So, the P total, yung P total natin is 94.4 kilopascal. Is equals to the pressure of our hydrogen gas. Nasaan na? Is the pressure. Ayan, pressure of hydrogen gas is unknown. Kasi ngayon, hinahanap natin eh. Find the vapor pressure of the dry gas, which is the hydrogen gas. Ayan, and the vapor pressure of water is 22.5 kilopascal. So, ang gagawin nyo lang dito, guys, is pagmaminusin nyo lang. Yan, transpose this to the other side. Transpose mo to sa kabila. So, magiging negative. So that you can get the pressure of the hydrogen gas, which is 94.4 kilopascal minus 22.5 kilopascal. Di ba, magma-minus ka lang. So, parang ang dali, di ba? And by the way, this is just a level 1 of our computations here. Kaya, huwag kayong makampante. Okay? So, ang ginamit ko lang na equation dito is the equation 1, which is the P total and ito, or whatever the gas present. Next naman, dito sa atin, same method lang din sa may number 2 natin. So, for number 2, guys, ang sagot dito, ayan, a gas is collected over a water at temperature of 35 degrees Celsius. Ayan. When the barometric pressure or the total pressure, kapag sinabing barometric, total pressure, PT is equals to 342 Torricelli at 742 pala, 742 Torricelli. What is the partial pressure of the dry gas? So the vapor pressure of water is 35 degrees Celsius. At 35 degrees Celsius is 42.2 torr. Sir, ba't po ganun? Ayan, kung mapapansin nyo, yung values ng water natin is always constant. Kasi nga guys, gusto ko lang pakita, kapag sinabing vapor pressure of water at walang naalagay na value sa problem, makikita nyo siya sa may internet, yung vapor pressure ng water natin. Ayan, makikita nyo siya dito. Sasend ko lang yung link, gusto nyo. Ayan, yung vapor pressure ng water natin at millimeter of mercury. So, constant na siya na makikita nyo dyan. Kaso, binibigay kasi siya sa may problem. Mamaya sa may sample problem natin na mamaya for the collection of potassium chloride is ipapakita ko kung paano nag-arise doon. Yung ating problem, sir. So, here it's just a, di ba, P total equals to the P gas. Hindi naman sinabi kung ano yung gas na present eh. Dito kasi sinabi hydrogen gas eh. So here plus the PH2O. Kasi nag-contribute lagi H2O, di ba? We have to consider that. So PT, ayan. So we have the P gas. So ang ginawa ko niya dito is nag-substitute agad ako ng values. Pero dito, ang second method na gagawin ko is to derive first the formula. So we have here the P gas equals, di ba? Pagka transpose mo dito sa kabila, magiging PT minus PH2O equals the PT or the total pressure is 742 Torricelli, and then the vapor pressure of water at 35 degrees Celsius is 42.2 torr. So ang sagot dyan is 699.8 Torricelli. So ganun lang, minus lang siya, di ba? Parang dali, di ba? Pero hindi tayo basta-basta natatapos diyan. Kasi we will have this third problem na kung saan gagamitin natin yung pinag-derive natin na sobrang haba kanina. Itong expression na ito, which is the mole fraction, di ba? Ayan. So, let's have here. Ayan, and let's go natin. So, dito, pang malakasan agad na problem natin dito. A mixture of 6 grams of oxygen and 9 grams of methane is placed in a 15-liter vessel at 0 degrees Celsius. So, 273 Kelvin siya. Tama. What is the partial pressure of each gas? And what is the total pressure in the vessel? So how do we do that? So ang derivations natin kanina, di ba? We have the gas 1 is equals to mole fraction of 1 and the total pressure. Tama. And then nag-derive din tayo kanina that the total pressure is equals to total moles V all over, sorry. NT all over RT over V. Tama. If you could recall, kung nagkaroon kayo screenshot kanina, yan yung mga equations na na-derive natin dito sa equations na dinerive natin sobrang haba. Yan yung gagamitin natin dyan. Pero, ang given kasi dito guys is masses. Mass. Hindi mole fraction, hindi moles total. Sa general chemistry niyo, di ba? In order to get the moles, babalik ulit kayo sa mga basics natin. So if you don't know the basics, may hirapan kayo dito. Kasakali. So di ba, ang mole natin is just a mass all over molecular weight. Tama? So here, sa 6 grams natin, 6 grams of oxygen. Ayan, so this is the formula. So we get the moles of oxygen. So ano bang oxygen natin? So 6 grams, ano ba yung mass niya? 6 grams. What's the molecular weight, di ba? May kita niyan sa may periodic table ninyo. And for the molecular weight of oxygen natin, that's 32 grams per mole. So saan niyo po nakita yan, di ba? Sa periodic table, yung O natin, di ba? May kita niyo is nakalagay dyan is 15.99 grams per mole. Since O2 ang present, so that is times 2. For the O2, that is 32, ni-round off ko na lang. So, walang calculator. Di ko natin. We have to solve this one here. Okay, so 6 grams. 6 divided by 32. Ang mole natin for oxygen is 0.1875. 0.1875 mole. And then ano pa yung gas na present? We have the methane, which is 9 grams. So the moles of methane, moles CH4, is ilang grams daw siya? That is 9 grams all over. Ilan yung molecular weight niya? That is 16 grams per mole. Ayan, so 9 divided by 16, that is 0.5625 mole. So 0.5625 mole. Ayan. So ang total pressure, ang una natin sasagutin is the total pressure of the vessel. In the vessel, okay? The total pressure. Kasi nga, bakit sir, bakit total pressure po muna? Kasi di ba, from this, we will get the NT, di ba? The moles total. So pagpaplasin lang natin yan, plus 0.1875, meron tayong 0.75 total moles. Ngayon, dito na natin gagamitin itong formula na to get the total, the PT. Ayan. So, PT, the total moles. Ayan. So, let's substitute the values na 0.75 mole. And then the R, gas constant. You're all familiar to this. Nag-aralan sa General Chemistry. That is 0.08206 liter ATM per moles Kelvin. Times ilan yung temperature natin? 0 degrees Celsius. Now, itong temperature natin is naka-Kelvin yan, guys. So, di ba, ang kwan natin, in order to get the Kelvin, that is degrees Celsius plus 273.15. Okay, since 0 naman, ang magiging kwan nito is 273.15 Kelvin. I'll drop the unit na lang. Ayan, so here, Kelvin. And then divided by the volume of the vessel. What's the volume of the vessel? That is 15 liters. Ayan, di ba? So, from this, makuha natin yung total pressure natin for 0.75 times 0.08206 times 273.15 divided by 15 liters. Ang lalabas ay 1.12 ATM. Ayan, so ma-cancel yung moles, ma-cancel yung Kelvin, ma-cancel yung liter, natira yung ATM, so that is the total pressure of the gas is 1.12 ATM. Ayan, di ba? So, ganyan lang. And derivations na ginamit ko kanina, I want to reiterate just to show na yung formula natin is Hindi lang basta-basta na nag-come up doon. May pinagmulan siya. Ayan, so kung ayaw niyong kabisaduhin yun, I want you to disregard that kung gusto niyo kanin. Just memorize this formula, ayan, and you will get the answer, okay? So that's it. Okay, take screenshot. So proceed to the next part. Okay. And then, let's back to the one natin. Ayan. So ang tanong naman dito, hindi pa tayo tapos. What is the partial pressure of each gas? Ano ba yung gas na present natin? We have oxygen and methane. Anong gagamitin nating equation for that? Ang gagamitin nating equations is itong first equation. Kung saan pressure of gas 1 is equals to mole fraction of 1 all over PT o the total pressure. Meron na agad tayong total pressure which is ito. Pero problema natin is the mole fraction. Madali na lang yon kasi nagkuha na natin tayo dito na takan na natin to. So just some sort of kuha natin, di ba? So pressure of methane, punta tayo sa pressure ng methane muna. So ano ba yung mole fraction ng methane natin, di ba? Di ba yung mole fraction natin, isingit ko lang dito, is the moles of 1 all over the NT. So the gas 1, moles 1, and the NT. So ano ba yung natin, yung hinahanap natin dito sa methane, di ba? So moles of 1, ano yung moles ng methane natin? 0.5625 mole. All over, ano yung total moles? 0.75. Okay. That's for the mole fraction. And then the total pressure is ito lang yon. So 1.12 atm. And then for that, we will get the partial pressure, ayan, 0.5625 all over 0.75 times 1.12 times 1.12 here. And you will get the answer na 0.84 atm. The answer for here is 0.84 atm methane. So, ayan o. Kita nyo naman, CH4. Now, syempre, since you all know that here, ayan. So, madali na lang din yung oxygen, di ba? So, P oxygen is just one fraction times the total pressure. It's just A, di ba? So, 0.1875 all over 0.75 times the total pressure na 1.12 atm. And you will get an answer. Siyempre, ka-calculate yan in order to prove our answer. Ayan, here. Ayan, so calculate ko muna din. So 0.1875 times 0.75 times 1.12, and you have the answer of 0.28 atmospheric oxygen. So 0.28 ang sagot. Diba? So 0.28 atm oxygen ang labas. So that's how you answer the questions involving the Dalton's Law of partial pressure. Di ba? Yung una, minus lang. Pero dito, biglang hirap. Kasi nga, pinakita ko lang that the significance of formula dun sa may sinabi ko kanina, which is this one. So there are two formulas na gagamitin ninyo, just such as the total pressure plus the addition of the each gas. And then the partial pressure of each gas using the mole fraction and the total pressure together with the ideal gas law. Okay, now let's level it up further. Okay, so take screenshot for the solution of this answer. So you can proceed. So we can proceed to the next problem. Yan, thank you very much, guys. Here and here. Okay. Now for the last problem of our discussion for the mixture of ideal gases. Here. So masyadong maliit. Ayan. So here, ayan. So takpan natin yung solutions para hindi nyo makita. Takpan natin. Ayan. Wait lang. For the last problem. Ayan. Okay, for our last problem. Yes, last problem na, sir. Okay, sige. Dito naman is related ito sa mga experiment niyo. But here in this problem is gumamit tayo ng volume instead ng mass. So this is the problem. When a sample of potassium chlorate is partially decomposed in the setup shown in the figure 10.15, which is this figure here, the volume of gas collected is 0.250 liter at 26 degrees Celsius and 765 torricelli total pressure. How many moles of oxygen are collected? How many grams of potassium chlorate are decomposed? And kung mapapansin nyo guys, hindi lang basta oxygen ang present dito. We have water, guys. We have water. We have water. Ayan, dito sa ating collection ng gas. And so the total pressure will be the pressure exerted by the oxygen plus water. And, okay, how many moles are collected before we answer that? Kasi in order to calculate the moles of the oxygen, we will use the PV and RT. Meron na tayong P, wala pa tayo, meron na tayong, meron na tayong, ayan, so let's isolate the N kasi nga moles. So N is equals to PV all over RT. Sa equation natin, we have volume. But what of pressure? Diba? Meron na rin kasi temperature ayun no, 26 degrees Celsius. So plus 273.15 lang yan. And you'll have a 299, diba? 299.15 degrees Celsius. Kelvin pala, I should say. And then here is ito, meron na rin 0.0206. Pero wala pa tayong pressure. So what's the pressure? So ang total pressure, hindi naman sir, 765 po. Hindi guys, that is the total pressure. Total pressure ito guys. This one here is total pressure. We have to isolate the moles of oxygen. Kasi nga, nag-contribute, we have to remove this. So, ang gagawin natin dito, ayan, transpose to the other side to get the moles of oxygen here, di ba? PT, which is 765 torr. Sir, what is the vapor pressure of, that's minus, that of water, di ba? Sinabi ko kanina that the vapor pressure of water is constant. Depende sa temperature. So, ang pa natin, based from the internet, or kung sa may table ninyo, ayan, ayan, so as shown in the table, ayan, so dito na tayo sa internet para mas accessible. So, millimeter mercury, guys, is equal to torricelli. Okay? Millimeter mercury is equals to torricelli. Ngayon, ilan ba to? So, degree Celsius. So, nasa 26 daw. Ayan, so 25.2 torricelli ang value or the pressure ng water natin. So, we have 765 torr minus, that's not equal, sorry, minus 25.2 torricelli. Okay? So, pag minusin mo lang yan, and you will have a 765 minus 25.2. Tama ba? 25.2. Okay, tama. Okay, so that will be 739.8. The pressure of oxygen. 739.8 torricelli. Na kung saan, pwede mo pa lang siyang i-impose dito. So, the moles of oxygen will be, ayan, so, asan na? P is 739.8 torr, but hindi siya sa torr, hindi sa may torr. Bagkus ay ATM ang gagamitin natin. So, how do we convert ATM to torr? Okay, per 1 ATM, there are 760 millimeter mercury or 760 torricelli. So, using some sort of dimensional analysis to convert this, so gagawin na natin is 760 torr equals to 1 ATM. Okay? ATM po ang unit na ginagamit natin sa may ating ideal gas equation. So, be careful with that, okay? So, the volume is ilan daw? That is 0.250. 0.250 liter all over the gas constant, which is the 0.08206 liter ATM times moles per Kelvin times the Kelvin. Okay, that's just a 273.15 plus 26 degrees Celsius. Ayan. And the answer. So, nagkaroon lang ako, direct approach ang ginawa ko dito sa equations. So, pinasok-pasok ko na lahat. Hindi na ako isa-isang nag-convert. So, that depende sa may technique ninyo. Pero, ganito kasi ang nakikita kong way in order to ease the calculations for this problem. Depende sa methods nyo, okay? So, ganun lang din naman, you will arrive at the same answer. So, ang sagot dito is 9.91. 9.91 times 10 raised to negative 3 moles of oxygen. Ayan. So, letter A is checked. What about B? What about letter B? How do we calculate for that? Now, dito sa ating potassium chlorate natin, ayan. So, may sagot naman na dito, pero hindi ko natin eh. Ano, saan nakuha itong mga values na ito? Saan nakuha yan? Kasi nga, we have to know the reaction. Sa decomposition ng potassium chlorate kasi, di ba, it's just some sort of simple stoichiometry. Mag-generate tayo ng potassium chloride plus oxygen. The reaction is not balanced, so babalance ka dito ng 2, babalance ka ng 2 dito, babalance ka ng 2 dito, and babalance ka ng 3, and the reaction is balanced, di ba? Yeah. So, meron ang moles of oxygen, co-convert mo daw siya into KClO3, di ba? How many grams of potassium chlorate were decomposed using the moles of oxygen? So, ganun lang yun. So, it's just a simple calculation here, the grams of the KClO3, dimensional analysis lang to. So, ano yung moles natin? So, 9.91 times 10 raised to negative 3 moles of oxygen, and then the mole ratio. Okay? Recall the concept of stoichiometry that you studied, that you learned in the general chemistry class. So, ayan, stoichiometry, and then, ayan, so mole ratio. For every 3 moles of oxygen, there are 2 moles of potassium chloride. 2 moles of potassium chloride here. Times the molecular weight. Siyempre, di ba, hindi mawawala yan. So, the molecular weight, titignan nyo sa periodic table, it's the sum of atomic weight of potassium, chlorine, and the price value of the atomic weight of oxygen. And that is, siyempre, nakasulat dito. That is 1.22.6 grams per mole of KClO3 per mole. Ayan, so makakancel yung moles of oxygen. Makakancel yung mole KClO3. Matitira yung grams KClO3. And then, syempre, hindi natin kung anyan, calculate natin just to be sure na talaga yung sagot times 10 times 2 over 3 times 132.6. And ang sagot is 0. Sa may calculator ko, guys, ang sagot is 0.0 ay 0.81 grams KClO3 na kung saan is parehas din naman dito. So magkalapit lang yung value. So that's it. Okay, for the natin. And I want you to take a screenshot for this so that you can solve the problem. Yan, take a screenshot, guys. And here, take a screenshot. Take a screenshot. Okay. So that will be our discussion for the Dalton's Law, partial pressure. And I hope you learned something. And the Graham's Law of effusion and diffusion are not covered in this module. So I think, yeah, basta ganun. The only scope of our discussion is just the Dalton's Law of partial pressure. So thank you guys for listening, and I hope you learned something in this discussion. Whenever you have questions, please let me know, and I am happy to respond. Okay, thank you very much, and goodbye.